In this video, we are going to be talking about the fluid properties that tie to all the calculations in the mechanical productivity pack. So we went round and round on the best way to do this because we wanted to release all of these families that all need to have the same values for given parameters, like for example, heating water. All the heating water coils need to have the same glycol percentage and type. So we struggled with the best way to do that. And the main reason is because Autodesk offers one solution and it just wasn't the perfect fit. Autodesk does offer global parameters here, and you can make a parameter. However, and you could edit one value here. However, this parameter needs to get tied to every family, and you can't tie it to the family until the family is already placed because it has to be an instance property. So that would have created, I think, a lot of inconsistencies in the designs. So what we ended up going with was tried and true schedules. So schedules, it doesn't matter whether something is instance or type. We can edit the values all the same in the families all at once. So these schedules search for specific properties, and we'll take a look at some of the filters. But essentially, they're not sorted or itemized in that fashion. So all the families now are stacked up on this one row, and now we can edit these values for all families once. These equations is where some of these properties tie into. These are also outlined in the user manual, but I put them here on the title sheet so users will see them. So these are right on the closeout view. So this is where people will see them every time they open the project, and they'll know if they place a new family and something's got another value, then they can go and update it accordingly. So let's look at a couple of these schedules. So design air properties. These design air properties are used in the heating coil calculations. I don't have that formula here, but it's in the user manual. Essentially, we're using density and specific heat to determine the factor, which most people are familiar with, which is 1.08 or 1.085. Altitude right now is not being used, but we included it here because I foresee another lookup table based upon altitude that would return these values for you. But right now, you need to edit these values based upon whatever your conditions are. And, if you're in most of the United States in lower elevations, these numbers you're never going to have to change. However, if you're in Colorado, you definitely would want to update these numbers. Now, an important thing about these properties is this does not update the duct airflow properties that Revit is using for calculating flow and pressure drop. If you go to Manage and go to MEP Settings, and I actually tell you right here, make sure you edit the air density value in the MEP settings, so mechanical settings, duct settings, this value right here. So this value is found in the families and it's being used in the calculations. This value is being used by Revit to do its duct airflow calculations. So two different places, but you need to edit them both. The design fuel properties now. So some of the cool things about this is the idea of editing multiple families with information in schedules all at once. So all of the gas-fired heating equipment, all of them have the type of gas, the pressure available. This is a hidden column, but essentially these two values show up in every gas-fired heat exchanger equipment. So if your building has 5 psi gas or 2 psi gas, you can go and update this in one spot. The other cool thing about this is, here, let me finish this. So if we change this to 5 psi, now all the schedules will indicate that accordingly. So we have included a heating value. We went through the gas-fired heat exchanger calculations, but we didn't really talk about this value. But this value does not have proper data types yet because they're not available from Autodesk, but essentially it's deriving CFH value from the BTU value. So in this case, we put the units for the parameter up in the header here. So this is a BTU per cubic foot value. 1,000 is fairly common throughout the United States, with the exception of, once you get into higher elevations, Colorado and places like that. And then also this allows you to calculate CFH with different types of fuels. So if we had propane, we could change the type here to indicate propane, and we could update this value, and now all of our CFH values and all of our gas riser diagrams will update that are being counted from the BTU load. All right, so that's design fuel properties. The other cool part about this schedule is that this is a multi-category schedule. So we have a fuel connector in the kitchen equipment families, and now you're able to edit everything across the entire model at once. Otherwise, these schedules are mechanical equipment schedules. So heating plant, cooling plant, and rejection plant. So essentially, there's three plants that I see throughout the building for water, and they each could have their own different glycol percentages and types. So we've broken those out. All the schedules, like I said, are using these parameters. Green values being the inputs, and then the white values are calculated values. Let's look at this heating plant schedule. So I have the equations up here for how this is being used. We're using it in the water flow calculation with entering and leaving water temperature, density, and specific heat. And these are coming from lookup tables. So how did we get these values? All of the mechanical equipment families that have it, that have heating, or that have a water glycol solution mix, have this lookup table. So we have some formulas in the families that will go to this lookup table, and based upon what type of glycol is selected, it'll find the next highest percentage. So if you had 22.5, you end up with values from 25. And essentially we're returning density and specific heat for calculating that factor, which on the water side, everyone's familiar with the 500 times GPM times delta T. So this is the table that's found in all the families. If you wanted to tweak any of these specific values, you could just edit them and reload it back into the families. So now what we're able to do with this is really cool, actually. Let's open up a couple views here. All right, so we've got a hydronic riser diagram. This is one of the sheets in the sample project, M902. So right now we have VAV boxes that are calculating GPMs based upon that heating load, which comes from the connected airflow. And then all of that GPMs are being propagated in the piping system. So if we have to update design values, here's kind of the power of this. We can go to this schedule here. So say we're not going to have glycol in the system. I'm going to uncheck this. So once again, this is processing a whole bunch of families all at once. So this is going to take a moment. And there we go. We just updated all the GPMs throughout the system. We edited many schedules for hydronic equipment. And I guess lastly here we would put this at 0. And now you can see that we're back to our factor of 500. And there we go. So it's up to you guys to be aware of these schedules and keep them up to date. We can look at one of the filters on these. So we're looking for families that have heating plant water density. The reason I search for that is because that is a calculated value in the families, and if you get families from a manufacturer and you add parameters to them, you can add the parameters from the schedule, which is the type of glycol and the percentage, and then those families won't get included in this list. Well, for one, because they're not using the equations. So, and then sorting and grouping, we're sorting by heating plant water density. So if there's some families that end up with different values, we'll be able to see that, and maybe I'll show you what that looks like. So let's go back to our tiled view. So say, for example, the boiler had something different checked. So say this was checked in the boiler family, heating plant glycol is ethylene, said okay. And then we'd have to give it a percentage. So if you just check the box, the density doesn't change. Let's give this a percentage. So here you go. So here's what you want to be aware of when there's multiple rows. When there's multiple rows, that's bad. That means your families are doing different calculations and there's inconsistencies. One row is good. And that is the design fluid property schedules.